Okay, so you do need a calculator always. I hope you got it, and you got your periodic table. What is the formula for percentage? Something over, you're close. It is times 100 will give you percent. But what over what will give you percentage? The what?
Part of a whole.
Part of a whole. So this is how I figure out your grade. It's the number of questions you get right over the total questions that are possible you could get right, times 100. So if you're ever wondering how I figure out why you missed so many points or something like that, that's the reason why. All right, so basically what they want to know is what the percent of water is. So you're trying to find how much of this whole compound is water. And that's it. So here's the thing. You remember this little dot from before? You did the formula mass a little bit before on one of those little worksheets. It was about like in Unit 4, and they saw the hydrates. Well, this right here is a hydrate. It's where you have ionic compound, but it's surrounded by water. This one right here is surrounded by 5 molecules of water. And so basically it's like this, and I'll try drawing it up here in the little corner. You got CuSO4 molecule. We'll pretend that's the molecule, okay? And then around it you got like H2O. And you got like 5 H2Os. That's basically what a hydrate is. They're not bonded, but they're kind of surrounding it like that. So that's what really this means. Okay? It does not mean multiply by. I know you're in math, it says multiply, but you might want to think that that's more of a plus sign. Okay? That will help out. But anyway, the first thing we need, though, if we're going to do the percent of water, the best way to do it is not by counting molecules, but by counting how much each weigh. So you're going to need the mass of this whole thing. So basically, you need to find the mass of CuSO4 plus 5 waters. Well, you can find 5 waters real fast. Remember I told you, does anybody remember the mass of water? 18.02. Well, if you got 5 waters, each at 18.02, just multiply 5 times 18.02. Okay? Now, I usually do them separate. There's a reason why I say do them separate. Because you're going to need the mass of just this over the whole thing. So let's go ahead and find the mass of water. All right, so when you add these two things together, you get this number. So this right here, the whole thing, CuSO4 dot 5H2O, this is your total. Okay, or your whole. So that's going to go right here. With me so far. What's going to be the part then? Is it going to be this mass or this mass? Well, the water thing, when you take 5 waters, 5 times 18.02, you just said it was 90.1? Okay? That right there is going to be your part. And so you're going to take that divided by your whole, 249.72 times 100, and that'll give you your percentage of how. Basically, you're trying to figure out how much of that whole compound is water. What percent is water? Why should you care how much percent of water is? Well, think about this. Every fruit, every vegetable has a certain amount of water unless you dehydrated it. Hence the name dehydrate. You remove all the water, which makes it, not so perishable. Do you round this? 2 decimals. 36 point, I got 08. But if you got like 36 something, you're good. You gravy. And that's basically how some of these are going to work. Now, you could do the next one actually by yourself real quick, because it's the same setup. Basically, a quick shortcut is this. Find the mass of each two separately, and all 9 waters. Then add them together, that's your whole. Then put the water over the whole. No, keep going. This right here, I don't know if you noticed the 5 in front, that coefficient that we've been using to balance with. That actually is, guess what? Your moles. So when you've been balancing, you've been putting moles. That's your mole ratio. 67.51%. So everybody know why we're putting the water on top? Because they asked for water. Okay. Now, if they ask for salt, and I'll go ahead and tell you, salt is not always NaCl. Salt is basically this thing on the side. Okay. Now, before we move on to this next part, this was just finding the percent of water. We hadn't talked about what the difference between a hydrate and anhydrate and Well, yeah, that's pretty much it. Up here at the very top, they do go over some of this stuff. They talk about water molecules are loosely bonded to a crystal structure. And when I say loosely, it's not kind of really a bond, it's like a fake bond. But as you look through each one of these, it says water and acidic ratio. The formula will always be around salt. For each compound, it's different. The next term you're going to run into here, if you have a hydrate, that means you have water. If you have anhydrous, what does that mean then? It means just the salt. Okay, and hydrate is basically salt with the water, like this, salt and water. That's a hydrate. Salt and water, hydrate. But if we dehydrate, like heat it up, and we remove that water, we end up with what's called the anhydrous salt. An, which means without. Does that make sense? Well, it doesn't mean without, it means no water, really, that's what it means. So basically what they're saying here in this next problem is you have a 5-gram sample of a hydrate, BaCl2. They're not telling you how much the water ratio is. However, they said after it was heated, it weighed 4.3, okay? Now here's the kicker. Before they heated it, after they heated it. What's the difference in these two numbers going to tell you then? The weight of the water. Everybody see that? So we have a sample, and this is what you're going to do in lab tomorrow. You're going to take a sample, you're going to heat it up, and then you're going to measure it a second time, and you're going to get it, it should be less than it was before because you basically heated out the water. You dehydrated it. And then you get your sample without water. Basically then they want to know what is the percent water that was in here. Okay, how would you do that? So we're going to subtract these two. We got to get that water, which y'all can do that in your head, right? 0.7. Okay? So 0.7 grams, this right here, I'm going to list this all out. This was the hydrate. This was anhydrous salt. This right here is your water. So 0.7 grams of this 5.0 is water. Okay? They want to know a percent. What's your part? The 0.7 water. And notice you don't have to go back to the periodic table on this. They don't want it in moles. So 0.7 grams over something to get us our percent. What's got to be our whole here? What was the thing that you started with that was not? The 5. Does everybody see that? So this is actually technically your total. That's your total mass. This is what happens when you dehydrated it. So you just take 0.7 over 5 times 100, and you should get a nice whole number. 14. Now, if they said what percent is the anhydrous salt, instead then you would use this as your part, but you still keep that as your whole. But they didn't ask for that. They just want to know what was the water in the hydrate. You should get another round number. 32. Not bad, right? So finding these percents are going to help you out actually down here. So these are the tougher ones, and these are the ones that you might want to know a little bit more. Those were actually the warm-ups. All right, so we're going to take this one slow because both of these are actually different. And I'm going to actually do both of them. So you got a 3-gram sample of Na2CO3, which is actually kind of like baking soda, is heated to a constant mass. How much anhydrous salt remain? Anhydrous, with or without water? Without. This has with water, right? We need to figure out what the mass is without. All right? And you're like, well, how do I do that? Well, go back to where I just talked about up here. We need to find the percent of this compound. Don't look at the 3 grams yet. Okay? That's what you're going to basically end up doing like you did up here. You need to find out now basically what the percent of water is out of this guy. Oh, I'm sorry. Let me back up. Not water, the percent of the salt. Because they're asking for the salt. Make sense? Percentage of salt. Before, actually they're asking for the final answer, which is how much of it remained. They're wanting it in grams. But before you can do that, you need the percent of salt that is in the compound. So basically you're doing the same stuff up here, but you're not doing it for water, you're doing it for salt instead. So we need to add up all this. And good news is it's a 1-to-1 ratio. So basically you got 18.02, which you know here. You just need to find the mass of 2 sodiums, 1 carbon, and 3 oxygens. And that's why I say do them separate, because most of the time you're going to need either the salt or the water with the whole thing. So they want to know anhydrous salt. Again, which you got your total. which is down here, 124.01. You know you're going to multiply by 100. The question is, which one of these two dardars has to go here to find the percent of salt? The salt. That's why I labeled them. It helps out. I like labels. So I got like 85%, 0.50%. Is that what y'all got? Now, that's not your answer, okay? But you're on the right track. You got to have this value now, and you're going to end up basically moving the decimal over twice and multiplying it by 3. I mean, unless you just want me to see me put it all in the formula. You do another percent problem. Did I do it wrong? 47? I guess I rounded. Let's do 47. 85.47. And that's what you're trying to solve for. Basically, 3.0 times 0.85. I mean, basically that's what you end up doing right here. And that'll be your answer. It's going to be a small answer. Because they're trying to figure out what percent of 3 grams is that. It should be less than 3 grams. If it's over 3 grams, you've got a problem. 2.56. That's actually right. Yeah. But if you list out everything, you should be fine. You got a 5-gram sample of this whole thing. Okay? When they say 5-gram sample of the whole compound, is that going to be your part, your whole, or total? Well, I mean, whole and total is the same thing. I'm sorry. It's your whole. So you do know that this is your grand total of the whole thing. It's heated, okay, which means you're going to lose something. What are you going to lose? This or this? This right here. By the way, why is there in there? That's what you're going to end up solving for. That's technically your x you're trying to find. Okay, so if you want to put x instead, yeah. We're trying to figure out what's that whole number that's going to go in front there. And the good news is it's going to be a whole number. So it's heated up, and so it lost water, and now the mass was 3.9. So it's kind of like doing what you did up here. We got our total right here. So that's the hydrate. That's with salt. Then we got our anhydrous salt, which means it's without water. So if you subtract the difference, you're going to get the mass of what? 1.1, which is the mass of the salt, the hydrate, or the water? The water. You're going to need that. Okay, that's always good to go ahead and get all 3 variables out of the way so you know where to put things where. All right, so this is where it gets a little interesting. This right here is H2O, okay? We need to figure out the mole of this. And so, well, we just did moles yesterday. We're going to convert that, grams of water, into moles. And we're going to figure out the molar ratio. Because if you haven't noticed here, there should be coefficients in front of each one of these little guys, which is basically a molar ratio. In other words, if we look back at the first one, what is the molar ratio between the salt and the water here? 1 to 5. Okay? So it's a 1 to 5 ratio. What they're wanting to find out, and if you notice, every single one of these guys is basically set to 1. In other words, your salt's always going to be 1. Okay? That's good, because then the water is the one that's going to change. You're never going to have more salt than you are water. Okay, if you're ever wondering that. So the guy on the right's always going to be changing. So that's what we're trying to find out. So basically, we know this guy's going to be 1. We got to figure out what the ratio this guy's going to end up being. And it's going to be a different kind of number. It'll be a whole number. It will never be a decimal. If it is a decimal, you round it to a whole. And that's the only time I'll ever tell you that. Okay, so to figure this out, we have our mass of, we actually have the mass of everything we need. Let's do this. We got 1.1 grams of H2O. Well, let's convert that into moles. Let's see how we can do this. Let's see if y'all remember. All right. Down here, let's find our molar ratio. 1 mole of water weighs how much? 2 waters, 1 oxygen. 18.02. Boom. All right. Which one of these 2 dardars has to go on bottom? 18.2. And if that goes on bottom, thanks. Here, take one of these. Don't forget to turn in your homework. 2 grams. Then the 1 mole has to go on top. And so what we're doing is just like what we did yesterday and the day before. So basically 1.1 divided by that, you're going to get a decimal. Give me at least 2 whole digits that are non-zero. I got this.
Yeah, I got that too.
All right, and I know this gets a little weird, okay? You're like, well, crap, what do I do with that, okay? Well, here's the thing. We got to set that mole ratio next to this guy's mole ratio. That's one reason why we needed the salt. So we do the same thing to the salt. We have 3.9 grams of salt. And I'm going to give you a little bit of time to figure out the mass of this guy. Or do you want me to go ahead and just give it to you? I feel like y'all did enough of that last night. Just give it to you. Okay, it's 187.57. Long story short. 1 mole of this stuff. Oh, by the way, I forgot to cancel out my grams. And you're going to get another decimal. Now, it's really weird, but when dealing with moles, you're going to end up with a ratio, and it's going to be whole number. And so what we do, instead of putting gram to gram ratios, that gets very complicated. It's kind of silly. We like to use whole numbers if we can in chemistry to make things a little bit easier on us. So what we do is this. We got to figure out this coefficient. Again, this is a ratio. So how can you reduce these ratios quickly to figure out what's the ratio between one to the other? It involves fractions. Divide. Which one are you going to divide by? Well, let me ask you this. Which one is always 1? The bottom one. So which one is it? It's going to be basically going on bottom here? The salt. If you set that to 1, this will change this ratio. So basically, you take these two guys and divide them. This on top, 0.061 divided by 0.021. And you can kind of do that in your head. Well, basically 2 going to 6 how many times? 3 times.
2.9.
And so you end up with 2.9. And here's the problem. You can't put 2.9 here. That's the problem. And this does equal like 2.9. So that is your x, technically. But what we do, just round it to a whole. So your new formula is this, basically. CuNO3, and don't worry, there's more problems on the back of these, so you can practice. 3 H2O. And that's actually what you're going to be doing tomorrow in lab. I'm going to give you a compound, and you're going to get like 2 grams of it. You're going to dehydrate it, and you're going to do the same little process. This is probably as hard as that gets, right here. And you will see a question like this on the test, I promise. You might see some others like these, but I'll tell you, anything I can ask you about hydrates is on these 6 questions. But for this front part, I want to kind of go through how to do percent comp, because this is not in your notes. There's other percent formulas, like this was percent of hydrates that you just did. This is percent composition. It's the same formula. It's always going to be the whole, part over whole times 100. So if you ever see the word percent, just write this down. And I promise you, it will work out every time. So how to do this. First off, you are not doing this by the number of particles you see. In other words, you're not doing it like 1 over 6. Where am I getting these numbers? Well, there's a total of 1, 2, 3, 4, 5, 6 elements. You're not doing that. We're doing this, it should really be called percent by mass. So guess what? You're going to need to find the mass, and don't put your percents right here yet, okay? Yeah, your final answers are going there. But you're going to have to do some work off to the side. So let me show you how to do the first one. You got to find the formula mass like you did last night. But you're just now then taking each part, putting it over whole times 100. So let's find the mass of KMNO4, which I have not got this worked out, so you're going to have to do this for me. Potassium 39.1, right? Yeah. 39.1. Manganese, 54.94. And 4 oxygen, 4 times 16. 64. I add all those together. Let's see, that's a 4, that's a 10, then carry the 1. It'll be 18, carry the 1 here. 10, 12, 13, 14, 15. Is that right? 158.04? Yeah. All right, so why do you need the total? Well, this is your total. I'm sorry, let me write the word whole. Whole is total, total is whole. So basically what you're going to do here is now, and this is one reason why I always like do the multiply here. You're now taking each one of these numbers and putting it over your whole. So part over whole times 100, and then you put your percent here. Part over whole times 100. Not 1 oxygen, but all 4. And basically you're telling me out of this whole compound, what's the percent of each? And here's the thing, when you add them all together, they should equal 100. That's how you can always check your work. Now you might end up with 100 and 0.01 or 99.99. That's 100%. It's going to happen. Let's see. Let me actually see real quick. 74 plus 34.76.
You said that our total going to equal 100?
It might be like off by just like a hair, like really, really like a 100th. Yeah, mine actually. This actually comes up. Mine came out to be 100. But like if you got like 99.99, you're good. If you got 100.01, you're fine. But it really should be within that kind of a range. This right here is rust. You have 25 grams of rust. They want to know how much iron, which element in here is iron, the Fe. So what we're going to do over here, I'm going to do the math up here so I can actually show it a little bit better. So this is your total mass right here. So you know how you did on the last sheet, you're trying to find the percent of the mass of water, but you got to find the percent of water first? It's like number 5 on this thing, right here. It's like that, but not as bad. You do the same crap you did up here, okay? You need to find the percent of iron in this whole thing. You don't really have to find the percent of oxygen because they just want to know iron. You don't really need the percent of oxygen on this one. So what you do, you find the mass. You have Fe times 2, which is like 55 point something times 2. What'd you get? 911? Okay. 0.7? Okay. So you got that. 3 oxygens, 16 times 3. 48? Yeah. Add those together. Well, you got to get to the percent. So this guy's going to be your part, and this guy down here, who's your whole, is going to be the whole mass. So you're going to find the percent by that. What'd you get? 0.7. Okay. So we don't need the mass of oxygen because they didn't ask for it, but you can get it anyway if you want to get the percent. So basically, you're taking 111.7 divided by 159.7 times 100. That gives you a percent of iron. That's not your answer, but you need that to get your answer. 61.94? Okay. Sweet. So now we just do like you did on that other sheet on the other number 5. What is your total mass of the whole compound right here? 25. You're basically taking this, put it 2 decimals over, and multiply it by 25. Your percent you just found? You're going to multiply it basically by this, but don't forget to move your decimals. To see it all written out in formula, it'd be times 100, 69 equals 69.94. Because that's the percent of iron. And your total was 25. And so you're just trying to find X. So what do you get on that? Somehow I remembered 17. 17 what? 49. Yeah. Notice it is less than the total, which is right. In other words, let's say this. If I gave you a question that said, I have 17 grams of iron in this compound, the grand total is this, what is my percent of iron? You would take this divided by this, it would give you this 69 again. So it's all about, these are all percent problems.